Good morning, everyone. For today, we talk about different process models to create software. For those processes, we talk about the activities that all of the process involve. From the activities, we talk about requirements. The first of the activities in most of the process models, requirements engineering, collecting the requirements, know what to do. And connected with the idea of requirements, diagrams. And for diagrams, we review use cases or user stories in the case of Agile, not diagrams, but at the end, documentation of the requirements. We review activity diagrams, state diagrams, all of those connected with the idea of documenting what we are going to do in more or less detail, depending on the process that we're following. In some of the process, very important to document all the details, waterfall. In others, middle point, user stories, Agile. And in others, we do not document anything. Prototyping. We have an idea, that's it. No need for documentation. We are not doing software that we are going to deliver to someone. Anyway, moving forward, the next activity, maybe the most important. We need to talk about design. We have our requirements, we have our idea, and now this is the middle point between that idea and start programming. You do not start programming from the requirements. You do not do that because one thing is the code, and a different thing is that code not only work, but have a good quality. And we need to talk about what is quality. Anyway, for the design, one thing that we already review is, well, the key element for the design is another diagram, the class diagram. Basically, you create a design and you show that design with a class diagram. The class diagram is the blueprint for your software. You can look to a class diagram, and that class diagram is going to show every single thing that the source code is going to have, in the same way that a blueprint shows what a building is going to look like. With the blueprint, you can calculate the quality, you can calculate the cost. We need to talk about it. Now, talking about the class diagram, talking about the design. Well, inside of this, we're talking about the object-oriented model. We're not talking about software design in general. What we are covering here is object-oriented software design, in the same way that you learn object-oriented programming with Java in one of your classes before. Everything that we review is in that particular segment, the object-oriented paradigm. Now, in that particular space, the only thing that we have in order to create a design is going to be classes. Obviously, that is the reason of the name of the diagram. And the question here, obviously, is what we do in order to decide how many classes do we have and what we put inside of those classes. Which methods or which attributes are public, private, protected. We need to talk about the decisions about what is inside. Moreover, moving forward, it's not only about what is inside of the class, what we encapsulate in the class. But maybe the most important thing, and we need to move forward in that direction, is the relationships. What do we do to connect one class with another, and another, and another? Because at the end, that is the software system. One class alone is not going to achieve almost anything. Well, your programming labs. But in the real world, the software is going to be more than one class, and they should be connected. They should work together. What is the best way to do the connections? And this is maybe the most important question of all of this. Which is the correct way to connect to classes? So far, what we have, something that we review, the things that you learn is, well, you can use inheritance, composition, aggregation, or association. But these arrows and classes, the boxes, what we're talking here is like zeros and ones for programming. Those are the core elements, the primitive elements. You do not do programming with zeros and ones. You can do it, but it could be a little bit complicated. You do not do software design only knowing these relationships. In a different example, when you learn programming, Java, you learn about primitive data types. You learn about integers, maybe. In a real world program, you do not use only primitive data. You do not use only integers. Probably what you have at least is this. And yes, these ones are inside of these ones, but the knowledge that you need for this and for this is just different. These are abstractions. These are trees, linked lists, stacks, queues, and usually you solve problems applying these things, not working with this primitive data. Something similar is going to happen with software design. And we need to talk about the equivalent to that for design. And I am talking about patterns. Obviously, particularly, I am talking about design patterns. This is the big picture about where we are and what we are going to do. Okay. So let's talk about object-oriented design and move forward to cover design patterns, what they are. Now, starting with object-oriented. In object-oriented, key elements that I need you to remember. In object-oriented, concepts that we're going to be talking about and need to know what they are. Abstraction, encapsulation, relationships, I mentioned that before, and polymorphism. There are other two, concurrency and persistency. We are not going to talk about this too. So keeping things simple, for us, object-oriented, key ideas, abstraction, encapsulation, relationships, and polymorphism. What they are, why they are important. Well, number one, abstraction. I could ask you, what is abstraction? And the picture in the textbook. The key idea when you define what is abstraction is that you have something, and when you create abstraction is reducing that something to one thing, and the important thing that you need to define is what are you going to be able to observe, to have for others in that thing. Talking about classes, yes, you can have a class cat, you can have a class Pac-Man, you can have a class student. Yes, you are applying abstraction. You are reducing a real cat, a real student, or an idea of Pac-Man in a video game to one class, to one element in a program. Now, the important thing for abstraction point of view is what is going to be available outside. What is going to be available outside? If you think about a class, what I am talking about is the public methods. Decision number one, in terms of abstraction, what you need to decide when you create a class, which elements of the class are going to be available for others. Because those elements that are available for others are the observable behavior of that class that others are going to have from your class. And remember, usually the idea is one programmer, one class. When you as a programmer create one class, whatever you put public is what are you going to allow others to use from your class, the services that you're going to provide to others. Not all methods are public. What you learn in programming, maybe methods are public. You can have methods that are private, methods that only you want to use inside of your class. You need to decide, up to you, which methods are public, which methods are going to be the interface for the class. The interface, yes, which methods can be used from your class to receive communication from outside. This picture, the idea of washing, is all about calling a method from the class. If you notice the arrow, it's exactly the same arrow that we used to represent in a class diagram calling methods. So, number one, abstraction. Yeah, reduce things to representations, but the more important part, which part of the representation, our classes, is visible to others, which methods we put public. Number two, that is about abstraction. The other key element in object-oriented, encapsulation. Encapsulation, well, as the picture, right? The things that are inside of the capsule. When we think about encapsulation, encapsulation is all about the inside. The inside, what we do not want to share with others. I am talking about whatever is private. And again, usually the data A key idea in object-oriented for encapsulation is, well, sometimes, most of the time, one key work for the class is to encapsulate, hide the data, information hiding. That is one of the most important things that you do when you create a class. The class is going to have some data, maybe some methods that work with that data, and they are private, protected. They are encapsulated. However, the class gives you some access points, the public method. Someone from outside can use that public method and maybe call a private method or maybe give you direct access to the data. This data is hiding data because the keyword for the class is information hiding. Abstraction, the public part. Encapsulation, the private or protected part. First two decisions that you need to take in your classes. Now, moving forward. Okay, I have my class and I have a clear idea about what is going to be private, what is going to be public, what is going to be part of the abstraction, and what is going to be part of the encapsulation. The next thing that I do is I need to connect my class with others. Now, connecting my class with others, something that we already review and you are experts is, well, you can use the relationship is a inheritance. You can use uses a, or you can use composition aggregation, has a. Three relationships. With those three elements, as I mentioned before, like the zeros and ones, you can start creating software and you can start connecting classes with other classes. That is the principle of relationships. Now, one key idea in object-oriented is those relationships should be hierarchical relationships. What I mean? Well, every single time that you connect two things, one is going to be superior, is going to be more important than the other. Think about the names. One is going to be the father, and the other is going to be the child. We need to decide which classes are going to be fathers, principals, and which one are going to be below. One is going to use other. Key decision is which one is going to be in this side, which one is going to be in this side. Having, obviously, we need to think about if it makes sense one class having another, or is maybe using the relationship that we need to create. We talk about this idea, professor, computer, student. What we want to do? A student is a computer? Probably not. Student uses a computer, or student has a computer. It's going to depend on the software that you're creating, but probably any of these two could make sense between the object and the element. But if we think about professor student in any of the two directions, professor has students, student has professors. Usually you do not use this term between these in any direction. The professor do not has a student. The student do not has professor, like having possession. Probably what you need to do between those two is use a using relationship, and probably the relationship is going to be bidirectional just trying to represent that professor call methods in a student or a student call methods in professor. Calling method is this idea of using, asking for something, right? Just remember, is can be in the software, extends, or implements. That is the source code for is. Inheritance, basically, realization. Having is the diamonds, and having is all about global variables. Every single time that you have an attribute and the type for the attribute is a class, you are using the having. Like if you have a class car and you have a global variable engine, that is having. The car has an engine and it should be global. It should be an attribute. Uses, the other cases. Which are the other cases? Local variables. If you have inside of a method a variable and that variable is from a class, what you have is using, not having. For having, should be global. Another one, call a method. If you call a method from a class and the method is in another class, you are using that class and it's your normal arrow. So that is what you have, zeros and ones, having, using, inheritance. But this is basically giving you the freedom to start doing programming. In some point, you're going to use global variables, local variables, calling methods, and well, inheritance. It should be a better way than starting from scratch every single time. We need to review. The relationship that we reviewed before, the one that I mentioned, names that hopefully you remember and can put in a diagram, association, aggregation, composition, generalization, and realization. Remember, for this one, realization in Java is what you know about implements. Generalization is extents. And can you explain me the difference? Extend, implement, when you use one or the other? What is the difference between this one with the solid line and this one with the dash? Well, this one is a class or this one is an interface, the panel. Yes, correct. So those are your zeros and ones. If I show you a diagram like this, something that we're going to review is you have relationships, and that relationships can have numbers and names. For instance, when you read this line here, number one, if you do not have an arrow, that means you have a bidirectional connection. Instead of two arrows or two lines, one for each line size, you can put only one. Moreover, you can put numbers, and this one apply to this one, and this apply to this. The reading is one of this, one salesperson is connected, association. One salesperson is associated with one or more orders. One of these is associated with one or more orders. You put the numbers. Diamond, composition or aggregation, again, no arrow, arrow. One order has one or more items. One of these, one or more of these, you know, items, rows, the name of the product, the price, whatever. Aggregation, If I do not put numbers at all, the understanding, the default is 1 and 1. I do not need to put numbers for that. One order, one customer. Use the line. Extra element for the line, adding numbers. The name. If we're talking about variables, for instance, this one, instead of having the variable here, whatever is the name, and the data type is going to be a particular class, I do not need to put this there because the class is this one. And the name for the variable, instead of having the name here, I can put the name here in the connection. It's very common with diamonds. Also, in this case, use note having variable, even though could be local, is not a diamond. Information for your diagrams. Now, we are not going to go into the detail with the numbers. We're not going to go into the detail with the relationships like this. The only thing that we're going to do is using the arrows. Make sure that you're familiar and capable of identifying all of this, when to use it. But again, they are zeros and ones. Anyway, we need to review. Now, we need to answer that question. The first answer for that question is, which one is the most important relationship in object-oriented? One thing that I can tell you about those three, the most important for one particular reason could be this one. And that particular reason is that one very powerful characteristic of object-oriented software design and developing is you need inheritance, because any child, any element that is inheriting from another element can take the place of that element. Data structures. In a data structure, if I do a data structure person, if I do an array of persons, but if I have a class person and I put childs to that class, student, professor, something that I can do is this array is not going to be only persons. That array can be person, can be student, can be professor, can be anything that I put as a child of the parent. And that is a very powerful attribute in object-oriented developing. Almost anything that we're going to create is going to have inheritance. And the reason because it's going to have inheritance is in order to have this particular characteristic of being able to use several different things in one single place. And I am using as an example the array. And the name for that is polymorphism. Yes, that is what you do with polymorphism. You have this common parent, and this parent have obviously methods. When you create this child is going to do the overriding of the method. When you do a for loop to iterate in this array of persons, it's not only that you can have in the array a person and a student and a professor, whatever, but when you call a method from the array X in the position whatever, and you call the method the method that you're going to call is the method that corresponds to the particular class of the object. So it can be M, and you're calling M from the position I of the array X. And you can assume traditionally that, well, all of them are person, and I am calling the same method. But that is not the case. You are calling M here, or here, or here. Dynamically, real time, this element in the array is behaving in a different way, running a different method. And that is the most important feature that you need to learn how to apply in your software. This is going to be the solution, or is the solution, for several different things. And I am going to show you some examples. So the last principle in object-oriented, and maybe the most important, and the one that apply and make this relationship so important, polymorphism. The quality of an object of behave in different ways, real time. It's the same idea. Remember, for the question in the chat about interfaces, what you have in an interface is basically a class that is not providing a body for a particular method. So if I make person an interface, the only thing that I have is this method empty. And I am forcing the child to provide the body. But the principle still applies, is when I put a common parent, all the childs, and not only the childs to the first level, but any child that I put to one of these, all the family can behave polymorphic. The parent, the top of the family, can be replaced for any of the childs or the childs of the childs and go down. If you think about using a library, using an API, most of the time what you do is you have some kind of software. I am sure that you remember JFrame in Java, and you want to create something, and the first relationship that you apply is what I can inherit. JFrame, you want to create a graphical user interface in Java. You do not start from scratch, never. Inherit from JFrame. That is inheritance without polymorphism. Later, I am going to show you what happened with those graphical elements that you add to the screen. You can add a panel in the same way that you add a label or a text field. Inheritance is one of the first things that you apply, and most of the time you take advantage not only of the inheritance, having the methods and the variables from others, but also from this. Replace the parent with the child's polymorphic behavior. So encapsulation, abstraction, relationships. One of the most important, if not the most, inheritance. And with inheritance, I achieve polymorphism. And those are my main principles. Okay, that is fine. But what is next? Well, next, you know what? Your goal when you are creating software is two things. Your tools are what I described before. Your tools is create classes. Your tools is connect those classes. One of the most important connections, well, create polymorphic elements. At the end, your software should have high cohesion, low coupling. Do you know these terms? Maybe they mentioned this in your programming labs. Anyone can help me with the definition? Why this should be high? Why this should be low? What I am asking for with those terms? Any idea? Okay, so two simple ideas. Number one, cohesion. Good. Thank you for the definition. Cohesion. What things should be together? This is the fancy term to define what is going to be together. What things should be close one to the other. What things cannot separate. For this, low coupling, separate. Let me be clear. The point number one about together is what you have inside of a class. Which attribute should be in which class? Because there is no more together than being the variable of a class. There is no more together than being a method and share the same class with another method. The definition is what is going to be encapsulated in which space. I want to encapsulate things together when they are related. And here, with this definition of together, I am using the example of methods and attributes. And one important thing that I need you to remember is when I talk about attributes, global variables, something that I am considering also is this relationship with the diamonds. Because remember, the diamonds are attributes, global variables. When you are using the diamond, doesn't matter if it's white or black, something that you are using, something that you are promoting is cohesion. Composition and aggregation, remember? If you have something composed, something else, they are together. Or if you are aggregating something, those two things are together. You need to be careful with that. Because if they are together, later, when you want to test it, do the testing of A, in order to test A, you're going to need B and C. They are together. The only reason because you use this is if you are 100% sure that forever you want those elements together. Inheritance is important. Usually, you are going to try to avoid these two. I am not telling you do not use them. I am telling you be careful when you use them because the connection that you are creating between the elements is a very strong connection. Be sure that you want that strong connection. The other one, low coupling. If you have decided that these two things are different things, something that you want is if you need to connect them, have the opportunity to separate them easily. Low coupling. You want to avoid having them with more than one connection. Easy to separate, right? One connection is easy to separate than two. Moreover, the easy connection to cut is association. Remember, try to avoid the diamonds. I just provide two examples, but just keep in mind, you want things that are common, familiar, related variables or connections together. But in general, what you want, talking about classes, packages, modules, being able to separate them easily. Because being able to separate them easily means that I can delete this one and replace for another class, a new version of the class. Or mean that I can do testing of B and I do not need to have A. And that is very good in terms of my software, the process. Anyway, obviously, here is like, okay, good. You are asking me to have things together, think careful about it, and think separated, think careful about it, but you are not telling me like there is some kind of recipe that I can follow for this. I mean, zeros and ones, I need to do programming with association, composition, aggregation, inheritance, and that's it. Obviously not. Next steps. When you create software, you do not use those from scratch. A lot of people create software. A lot of people have the same problems that you have, always. Usually what you do is to reuse solutions that someone else create. I am not talking about copy-paste source code from the internet. Solutions that someone else create are like Lego blocks for programming, Lego blocks, templates. Usually, you do not want to start from scratch with the zeros and ones and the relationships. You want to put together things that someone else have used. Moreover, things that have proved to be good solutions, and you solve your problem. That Lego blocks are what we call in software patterns. Patterns. There are solutions for particular problems. To be clear, one pattern solves one problem, and the solution is a design, a template, yeah, a class diagram. What if you have a problem in software and there is already a solution, and that solution is documented with a class diagram? The only thing that you need is in that class diagram to replace your particular classes, follow the diagram, do the same connections, and done. Your problem is solved. What if your class diagram, instead of being a collection of classes with these three different kind of arrows, is a collection of patterns, a collection of class diagrams, small class diagrams, Lego bricks that you put together? You're going to use inheritance and you're going to use association, composition, and so on, but not to connect classes individually, but to connect small blocks, small class diagrams, that together are going to be the class diagram for the problem that you are solving. Okay, looks like, well, okay, you are telling me that there are class diagrams for particular small problems. So if I have a problem, one of those, I can choose a class diagram. I am going to have the class diagram. I connect that one with another solutions, and together, like with the Legos, I create my software. So instead of solving something from scratch, I am going to search for solution, like searching for the bridge in the Lego that I need, and put together with the others. And in some point, I have my software done. Yes. Okay, patterns. Those fancy class diagrams, those solutions for existing problems. How many do you have? Well, the core, 23. 23 design patterns, the principal ones. The principal ones, usually they are called the GOF patterns. GOF, gang of four. Gang of four, yeah, because the authors. 4 people, 4 authors, the 23 patterns documented in this book. In particular, if you are going to work in the software industry, if your major somehow is going to be related with software design, programming, a very good lecture for you. Read the book. Anyway, obviously, we are not going to review the 23 patterns here. The only thing that I want to do is to give you an idea of what they are, but very good lecture, very good task for you. Learn about these 23 patterns from those 23. Those 23 patterns are separated in three categories. There are behavioral patterns, there are creational patterns, and there are structural patterns. You can figure out that each category solves a particular group of problems. This one here, behavior. Behavior for what? The behavior for your objects. And you define that inside of the class, obviously. There are some particular behaviors that I want in some classes, and I am going to talk about one, that they are already programmed. They are already there defined how to do it. You just need to take the pattern. Creational, create. Create what? Objects. There are particular needs when you create objects. We're going to review one. And obviously structure. Structure, connections. There are particular connections that you need sometimes in your project. Let me be more specific. Behavior. One of the most common behaviors that you want between two classes is that one class needs the information that another class has. It's one of the most common behaviors that you have between two classes. Objects from one class need access to the information in the other class. The information here can change, and this object need to know that that information changed. That have a name. The pattern is the observer pattern. Observer, yeah, because this guy needs information from the other. The idea that we define, the class diagram that we're going to review is, well, B is observing A. Observing, yeah, if the information in A change, B is going to be aware because B is observing A. How do you program that? There is a class diagram for that. Observer. We're going to review it. Now, creation. You can imagine the idea here, factory. One of the main recommendations in software is you do not put news in any place. You learn to use the new keyword, the Java, creating objects in any class. So any class can create an object, any method have a new. That is a very bad technique in programming. Usually in software, you put your news in a particular place, maybe in one class that is the one responsible for creating objects, for do the news. And you can imagine that maybe that class can have a name related with the idea that is a factory because it's creating things. Obviously, it's not only the class, it's a full structure that I need to show you, but you can get the idea. Creational patterns, create objects. It's not just about news in every single place. It's about, okay, one place should be responsible and how we define that place. I am sure that you have created software, and sometimes in the software, you want one class, and that class can create only one object, no more than one, only one. And you need to be sure that in your software, that is in the source code. Oh, that problem have a name, singleton. And you can be thinking right now like, one class and you only want one object, like for what? You have a database and you do not want concurrency problems with the database. You have only one connection to the database. Maybe you have an object. That object represents the connection. And something that you want is one and only one connection. Because if you create more than one, then you have two connections, and two connections mean that this can be reading and this can be writing. There are different solutions, but one solution is let's have only one connection. And this connection, if you are reading, you cannot write, or if you're writing, you cannot read. One single object connection, for instance. Structural. We're going to review this one. Sometimes when you are connecting things, one interesting connection is, you know what? Sometimes you have an object, a class, and that one is important and is connected with another class. But you know what? This one is called a decorator. A decorator. Yeah, it's like, I want this guy with the flower. So one class is the guy and the other class is the flower, and I need to connect them. And I need to be sure that it's clear that the flower is just decorating the guy. I am sure that now you remember the extents in the use cases. Sometimes those extents are implemented with the pattern decorator. And now we are connecting requirements with the design. And obviously that design is going to become source code. Anyway, I am talking about names. If you notice, most of the patterns have fancy names. The reason for the fancy name, singleton, prototype, factory, decorator, observer, interpreter, strategy, is that they are easy to remember. Moreover, easy to remember, and I can be talking with you. We are in the same team, and I can tell you, you know what? This problem, we can solve it with an observer. And I do not need to explain you the class diagram, because the idea is that we both know the class diagram. And the name of the diagram, the name of the pattern, help us to communicate. That is the second goal of the patterns. Not only the solution, but also improve communication. Anyway, we need to review this. The theory looks good, hopefully, but I want to show the source code. I want to go and implement software. Okay, so your software. By the end of the next week, my goal, you create classes. Each of those classes is going to have a particular role. I mentioned observer, I mentioned factory, I did mention decorator, and others. If we can create classes and we can assign each of those classes a particular role, these roles define how the classes are connected with others. Moreover, those roles define that maybe this factory is not going to be one class. It's going to be a collection of classes, even interfaces, connected in a particular way. So what I originally think about one is really going to be 3 or 4. When I look in a class diagram, if you have experience with design, what you are reading is trying to find patterns in that diagram, because the patterns is going to help you to understand what is happening there. There is a factory. Whatever is the name of this class is creating something. There is an observer. Whatever this class is doing is getting information from some place. Decoration. Okay, this is not important, but is complementing other class, other objects. This is what you read. Now, great, fancy. Let's work with the first one. Observer. Observer. Every single time that you do the following, you can use an observer. An observer. You have an object, a class, remember? Behind any object is a class. You have a class, and that class have information. And you have other class or several other classes, that want to know about that information. Observing. Examples. Do you remember the Pac-Man video game? And do you remember, hopefully, that the Pac-Man is one class? This little guy, the yellow circle, is one class. And you have this information, X, Y coordinates and draw for the Pac-Man. The ghost are also a class. You have a class ghost, and they have X and Y position, and they have methods. Can you agree with me that the ghosts are observing the Pac-Man? If I tell you the ghosts are observing the Pac-Man, immediately you get the idea that, yes, the ghosts need to know the information, X and Y coordinates of the Pac-Man, because if you play the game, the next movement of the ghost depends of the position of the Pac-Man, because the idea is that they move toward the Pac-Man or run from the Pac-Man. Observer is a relationship between those two classes, the ghost and the Pac-Man. Is the solution for your problem sharing the position of one with the other? Well, this is video games. Another one. You have a graphical user interface, and here you have some controls, sliders, or if not sliders, dex areas, a place in which you are going to put a number. And then you have a graphical space in which you want to plot that number or change something according with whatever you did here. This one is a class that maybe have the controllers. It's a class that maybe is inheriting from JPanel. It's a class. And this other is another class. And maybe this one is also inheriting from JPanel. But whatever is this class A and whatever is this class B, A, the information here is something that you need here. What you need to do is to implement the observer pattern between A and B. Observer. I am sure that you have worked with listeners in Java. Listeners in Java. Let me be clear. What you do every single time that you implement a listener in Java, you are working with the observer pattern. The creators of Java use the observer pattern that I am going to show you for the listeners. Observer, listener. Let's change the name, but the idea is the same. I am observing the data. I am listening an event. An event is data. It's a particular implementation of this. Why this is important? Well, what I am showing you is the theory. You want to go to the solver. This is the solver. This class diagram is the solution for two classes that need to share information. You can notice some comments, but the most important thing is you have this class and you have this class, another one. Always, 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 the solution for two classes that are sharing information is going to look like 4 elements, 4 classes connected with this shape. When you look at this shape, the other boxes are comments. That one is an observer pattern. And what is happening there, even without reading the name of the classes, is one need information from the other. This one can be the Pac-Man. This one can be the ghost. The connection between them is association, inheritance, association. I follow the class diagram. I do these connections. I obviously provide these methods is a template. Those methods with those connections, those solve the problem of one class sharing information with the other. Okay. How is that happen? Well, very easy. Number one, this one is the subject in terms of the pattern. The subject, as I mentioned before, the one that have the information, the Pacman. And that one is going to inherit from a parent inheritance, remember? If you are using Java, this parent class for the observer pattern is going to have a particular name. It's not subject. In Java, this class is observable. You have that class in the Java util package. What I am going to inherit from that class? Simple. You are going to inherit a method for adding, a method for removing, and a method notify. Adding, removing, what? Observers. This is a class. I am the subject. And someone is going to tell me that someone else is observing me. Someone, another class, is going to give me the information that you are observing me. And what is going to happen is that I am going to store in my memory a variable here, all the information about the people that is observing me. Obviously, in some point that people can stop observing me, remove. And what is going to happen is, whenever I do something important, my method notify is going to tell all those people that I know is observing me that I just did something. Think about you doing an exam. The instructor is going to tell you, I am observing you. You are the subject, you are the observable. I am observing you. And what you are going to do is every single time that you cheat in your exam, that you copy an answer from your classmate, you are going to notify the instructor. I just copy a question. It's not exactly what's happening in the real world, but that is what's happening in programming. In programming, you're asking the subject to notify the observer, the other, that something changed in the information. Adding, removing, notify, even the data structure in which you are going to store the reference to the people that is observing you. All those things are not part of the Pacman. All those things are not part of this class that is solving a particular problem. But all those things can be in a parent class. And when you create this child, when you connect the Pacman as a child of observable, what you are doing with the relationship inheritance is providing the Pacman the characteristic of the observable, the characteristic of remember that someone is watching and remember that he needs to notify every time that he moves or every time that some information changes. On the opposite side, here I have the class that is going to be receiving the information that the observable did something important. I have here the class Ghost, for instance, the class that is interested in the information from the other side. And what I am going to do with that class is implementation of a particular, usually an interface. In Java, this one is an interface. observer. And that interface, also in the Java util package, define a particular method. That method is the method update. It's an interface. The method update is empty. But when I do this inheritance here, what I am asking is this ghost is going to have a method update. I am making mandatory for the ghost to have an update method. And you know why? Because this method notify here is going to be calling that method update every time that this guy, the pacman, move. The method notify that the pacman is inheriting is going to be calling the method update in the ghost. And I am sure that the ghost have a method update because I connect the ghost with observer. And this connection is the association there. Now, what is going to happen inside of the update method? The update method is telling the ghost that something happened with the pacman. This can call a method in the pacman and ask the pacman, give me your new position. You notify me that you are doing something important. Now I ask you what you did. 2 inheritance and 2 communications. That is the solution that covers any possible necessity in sharing that data from one to the other. Now, I mentioned the listeners before. Help me. What do you do when you have a class and you want to use the mouse? What do you do when you have a class and you want to use the keyboard? What do you do when you have a class and you want to check for a click in a J button? What you do is your class implements inheritance from a particular class, something listener, observer, listener. And what do you need to do inside of the class? Provide a method, update. Well, wait, the name of the method is not update. For the listeners, action perform, action listeners, key something, mouse something. You provide those methods here, right? Who is calling those methods? Because that method is called every time that a click happens. That method is called every time that the mouse moves. That method is called every single time that a key is pressed. Who is calling the method? A notify method. Where? In another class, the observable one. And what is that class doing? That class is connected with your keyboard, system in. That class is connected with your mouse. There is a class that represents your mouse, but you do not work directly with that class. It's a low-level class with the keyboard. Obviously, there is a class that represents every single graphical widget in the graphical user interface, the label, the buttons, and so on. You don't care about the class. The only thing that you care is that all of these are subjects, are observables. And therefore, you can create a listener, an observer that observe them. And the only thing that you do is the inheritance connection and the definition of the method, because that is half of the work. The other half is already done. The observer pattern, the listeners in Java. Hopefully makes sense. Don't worry, I am going to show you the full source code, but this is the big picture. This is your solution to share information. Now, another one before moving to code. Decorator in structural patterns. Decorator. You know what is the key idea? I have an object, this ball, and I want to decorate the object. Decorate is literally put the object inside of another object. Okay, put the ball inside of the box. And the question that maybe you are thinking is like, and I can put that box inside of another box, and that other box inside of another, and I can continue. I mean, I can continue decorating things. Yes, you can do this. I mean, that is the idea of decoration. Well, wait, can I put inside of a box something like a ball, but also another box with a ball? So it's like I want to put one ball in a box, but then I can have another box, and that box have the previous one and the... Yes, you can do whatever you want. This is decoration. Can you think about one place in which you use this idea in Java? And I am hoping that immediately you are thinking about your graphical user interfaces. Do you know that you can put a panel inside of a panel? Or you can put inside of a panel widgets, like the ball that I showed you before, because you cannot put anything else inside. But you can put these two panels inside of another one, and you can continue with this forever. That is the idea when you learn how to use graphical interfaces swing in Java. You're familiar with this. Obviously, you can just put a ball, 4 balls inside of 5 inside of one box, the easy graphical interface. Or you can have this one that have inside 2 boxes, and then inside 1, 2, 3, 1, 2, 3 things. Any combination is valid. This idea is this idea. A pattern, a class diagram. This is the class diagram. This is the solution. You do not need to know inheritance, composition, association, separate. Is you know what? You have a problem. Your problem is that you need to put things inside of things for whatever reason, like for the graphical interfaces. Okay, easy. What you need is a common parent for everything. Remember, polymorphism, inheritance, the most important relationship. You need a common parent. And you're going to define as a common parent for that one, 2 childs. One child is going to be like the ball, like the thing that is the last one, something that cannot have other things inside, the element, and you're going to define another child. And the other child is going to be like the box. This one can have things inside, by him itself can be inside of others. Hopefully makes sense the inheritance here. Because what I am doing with inheritance is I am telling you that A can be B or C. And then from this child is used inheritance, but for the box, I have a diamond here and this connection. And I need to be sure that it's clear that I have a parent. I am creating a child, but I am telling the child that the child has a parent. Inheritance and having between the 2 same classes, yes. And you know what is going to happen? That if I create an object C, well, C have a variable, because remember, this is a variable, the diamond. And that variable is from the type A, the parent. And that basically means that I can put like this, and I have a C with an A inside. But just with those connections, I can have a C, not with an A inside, but with a B inside. And if I have a B inside, sorry, a C inside, the other child, if I have a C inside, well, that one can have inside another one. And that other one could be another C or a B. And this can continue forever. Is this? Okay, guys, I am going to stop here. Next week, we continue with these patterns and object-oriented development. Any question, send me an email. Thank you.